So hi, my name is Daniel Valdivia. I'm an engineer here at MinIO, and I'll be giving you a demonstration of all the capabilities that MinIO brings to the table from a perspective of a hybrid cloud deployment. So I'm going to be showing you first three things, right? First, our multi-cloud, deploying a multi-cloud object storage, right? It may sound intimidating that I'm actually taking three different clouds, and that's a challenge, right? Every cloud is doing things differently. But thanks to Kubernetes, I'm getting like a standardized platform. And even though each cloud is giving me a different flavor of Kubernetes, I'm actually leveraging the MinIO operator so I can actually have a standardized way to deploy storage across all of them and making it seem like one. Then I'll go and show you how, after I have deployed a MinIO operator on top of the three different clouds, I have a same consistent experience, right? Both for managing the infrastructure as the IT department, that's what matters to me, right? Being able to provision and enforce basic provisions from the company, right? And then I'll be showing you how you can actually delegate what matters most to the application team, which is managing the object storage. You can manage that yourself, or you can just pass it on, right? And then lastly, I'll be showing you what this brings, an advantage that this brings, which is, you can take your software and deploy it across different clouds, and it's the same application running on different clouds, which receives the same type of storage layer.
So you're talking around different clouds and so on. And before, Jonathan was touching on enterprise-grade capabilities. So do you have a way to replicate data from one cloud to another, to do migrations and things of that kind with MinIO?
Yes, and that is part of our demo. So part of the challenge where I've set up three different clouds, right? It's so that I can actually replicate data in both active fashion from across three sites, right? In this case, my sites are different clouds, and it can actually help us to do a fast failover, right? If a whole cloud goes down, right, your applications can pretty much fall back into the next cloud, and you're still online and in business. Last part is that application, that's portability of your applications, right? So you can run your applications on any type of VM. It really doesn't matter, but is the storage layer the same, right? That is not the case for clouds. That is not the same for on-premise. But with MinIO, you gain that advantage, right? MinIO will bring that consistent storage layer everywhere, performant, scalable as well. So I'm going to start with the demo. The first part is just showing you what I set up, right? I set up the three different Kubernetes flavors. One for Google Cloud, they call it GKE, right? Google Kubernetes Engine. Amazon offers the Elastic Kubernetes Service, right? EKS. And Azure offers AKS, right? Azure Kubernetes Service, right? So each of them have different capabilities. They all, at the end, it's Kubernetes what I care about. And I want to start with this just to showcase that, right? It really doesn't matter. Even if we added the on-premise as well deployment, we will have the same. Now, even though all of these create different complexities, right? Each cloud has its own identity management, right? So I can actually bring the identity manager that my organization uses, and that's why I can actually create a simple global way of accessing any of these clouds. So that's already reducing the complexity that I'm getting from deploying across different clouds. So that's where the MinIO operator comes into place, right? So if I'm going to go into any of these, right, I can protect the access to my applications with external identity providers. And right, my first instance is my Google Cloud instance. I'm logging in, and I have here three MinIO deployments. I can go to my, I think this is EKS. Yeah, I have a single tenant on EKS. That's on Amazon. I can, again, do it the same. And you get the same idea, right? Doesn't matter which cloud I'm going to. The complexity of how do I get into that cloud, it's gone, right? It's the same consistent piece of software that I'm using all over the place. And you can see I'm deploying different.
As you're talking about unifying the authentication, so far you're just showing authentication to the management portal. To be clear, are you unifying authentication for anything beyond the management portal?
Yes, but this is not only for management portal, because when we reach the part where I'm talking about the object storage, right, which is our main product, I'm also protecting that in a consistent way, right? So I don't have to be setting up accounts on different clouds, right? The external identity provider is giving me this control as the IT department of how I control access to these different resources across these different clouds. But for me, it's just different domains. Doesn't matter, like the user that ends up using this MinIO, right, doesn't really care which type of infrastructure he's running on, or the complexity of you have to use this type of volumes or this networking or these rules, right? That's already taken care by the MinIO operator.
Is there still a capability of allowing per cloud access to the storage, or does it have to be done through MinIO from an identity access management?
Yeah, so you can any day deploy MinIO just on one of the cloud, one of the regions, right? But the way applications expect, or from the admin DevOps point of view, if you are inside AWS, right? So you have different regions, US East, EU1, EU2, or APAC. There are different regions. You create some buckets here, some buckets there. But from applications point of view, all you need is an endpoint, bucket, access key, secret key. And authentication wise, like you don't really look at these are separate clouds. Within AWS, it's one cloud. Unified identity, access management, encryption keys, all of them coming from one cloud. What MinIO is doing is giving you the same experience, but it spans across clouds. That way, the identity can come from your enterprise identity or one of the cloud provided identity, or maybe entirely outside like Auth0 or Okta, something like that. Then key management service, for example, some of these InfoSec teams from the enterprise team are paranoid, and while they like cloud, they want the master keys to be kept entirely outside of the cloud. Right. Even if you are the DevOps, you are the admin, you cannot read the data. You can have root access to the backend, whatever, but you should not be able to read the data. And the key is coming from outside. Similarly, access management policies, compliance, like all the ransomware protection, immutability, compliance governance policies. All of this, how do you even come up with one policy definition that applies across cloud? There is no standard. S3 API versus GCS versus blob is just a small part of the bigger problem they have. It's everything that from as an admin, as an basically infrastructure admin, as an object storage admin, then from applications point of view, there are multiple standards. Unifying all of that in a way that it feels like it's one AWS, but it spreads across is what the demo is about. The management console, what is using for single sign-on, the management console itself, if you notice in MinIO, it's actually embedded inside the MinIO's 100 megabyte binary. It's a single static binary. It uses the same authentication mechanism that when applications uses to access an object, it uses the same single sign-on for the management console too. And when the application switches from one cloud to another, so if you put a global load balancer or some global round-robin DNS, application won't even know which cloud they're talking to.
All of this is coming into the same binary. And even though you're deploying across different clouds, MinIO becomes that one-stop shop that brings and unifies all the external entity provider management for access control, right? Everything that's like he was talking also about the KMS, bringing different types of KMS. And lastly, and the most important part is this consistent storage layer, right? That reduces the complexity by a lot. Your developers no longer need to worry about, okay, what's the API that I'm going to use in this cloud, right? Because every cloud has a different storage API, right? Azure has Azure Blob, Google Cloud has GCS, Amazon has S3. And guess what? MinIO is 100% compatible with S3. And there's this huge ecosystem of applications and frameworks that already have native support for S3, right? So one of the important parts that we wanted to kind of like highlight is actually all of these parts, all the delegates that are on premise are also missing all this commentary. I don't know if I should continue or it just struck my mind.
When I create a bucket from the last slide, for example, does it immediately, let's say, create an S3 storage, like via an API call, for example? Because when I read the blog, they said MinIO, like it kind of like it acts like a cache, and so, actually storage to S3. So I think I'm not pretty clear there.
Okay, sure, that part. So we are not creating anything on S3. So only our API is 100% compatible. And why it matters is so that if, let's say, on one part of the demo, I'm going to be showing you a TensorFlow application I wrote, where I just pointed out to an endpoint, a MinIO endpoint, and then that TensorFlow thinks it's talking to S3. Now, our infrastructure, let's say it's running on Google Cloud, is using Google Cloud persistent drives, and then it's presenting itself as object storage, right? So we're not actually creating a bucket on the infrastructure for Google, or even in that matter on Amazon, right? We're only leveraging their virtual machines and their persistent drives to build the object storage layer ourselves. So you're no longer constrained by the global namespace on Amazon, right? So on Amazon, if someone claimed the bucket with the name of your company, you can no longer claim that. But now it's your own namespace, and you have your own namespace on a per cloud basis. So you can go to all these different clouds and have the exact same bucket names as you want. And this is built into the story of fast failover between clouds, right? Which is another part of the demo that I'm going to be showing you next, right? So when you have different clouds and you say, okay, I'll be pushing a file over here, and then we'll run to the other two clouds and refresh, and you'll see the files landing there. And then you're going to drop a file on any of the other two clouds, and they're going to come flying into the other two. So that's the part where the advantage of running your own object storage infrastructure, and it's completely decoupled from what the Amazon S3 API offers, right? It's the same API, but not the same infrastructure as Amazon. Amazon can go down any moment, and you fail over to Azure or Google Cloud, whatever you prefer.
Wow. Okay, that's cool. That's cool. So let's say I have like 10 gig.
Mm-hmm.
For example, once Amazon just fails, it immediately just transfers to like maybe GCP or Azure, for example, right?
Yeah. Yes. And that's I don't want to spoil the fun, but I have a demo set up like that. You see, I have 3 windows here, and we're going to be dropping files. I can even give you a little pic on top of that. So the only difference that I have here about all these 3 clouds that I'm loading right now is that they have different URLs. There we go. So let's say I have my bucket on Google Cloud, and the main difference you'll see it's I'm running things on different domains, right? Because that's how I'm resolving to different clouds. And I have my active replicated bucket. This is a multi-site replicated bucket. So now if I drop a file, right? So as soon as this file is uploaded here, I can go to my clouds and refresh, and they will be immediately replicated all over the place, right? So this is the active replication support. Now, Amazon can go down now, and my files are already on other locations, right? I don't have to specifically go and replicate my data or be out of business for a couple of hours until they resolve the problem. No, I can fast failover, right? And then the same happens, like right now, this is EKS, my EKS cloud. I initially dropped it on my Google Cloud setup. So if I drop a file over here, right, I can go to Google Cloud, and let's say the same thing happens. Someone on Azure got it, and someone decided to delete that file, right? Which is like, oh, we shouldn't have that file online. I'm going to delete that, and then that will also propagate to other clouds. So you see, it's consistent, it's highly replicated, it's highly available. It helps you combat being available, right? And this is the same you will gain also if you were on premise, right? So if I had one more deployment running Red Hat OpenShift or VMware Tanzu, and I had this deployment as well, I will get the same capabilities regardless of which type of technology that I'm deciding to use to run my infrastructure on.
Do you actually have any way of enforcing compliance here to make sure that you aren't actually replicating things to locations they shouldn't be replicated to, or ways of preventing people from removing things that they shouldn't?
Yeah.
Yes. And I mean, and also, do you actually have any way of enforcing compliance in terms of location, where certain things, certain types of data can't be actually moved to places outside the country, or information, certain information can't be shared with certain people? What type of compliance do you have for that?
Sure, that's also part of the second part of the demo, which is part of the continuous data protection and object locking. We do have capabilities to control specifically, just not replicate the whole bucket. I only want to replicate this bucket or this part of the bucket into this location, right? So perhaps you're only setting this active replication across Europe because you don't want the data to leave Europe, let's say. We have those mechanisms. You may want to say, I want to enforce object locking, which is pretty useful, right? So that's the part. So from when you're inside MinIO, and this is part of the demo as well, when we are letting you use this user interface so you can discover the MinIO features. As you're creating a bucket, you can see that, for example, if I say a bucket is going to be created over here, and I can enable versioning to avoid, so if files get replaced, I can see the previous versions, but locking is what you were asking, right? So if I want to enforce warm, right? Write once, read many, and I don't want people deleting, right? I can actually do this. This is a great tool for ransomware protection, But then perhaps, for compliance reasons, I need to keep the data for 6 years or something like that, right? I can enforce a compliance where it says, this data will be here for 6 years, then it can be deleted. Perhaps it's something more lenient, 180 days, right? After 180 days, the data can actually be expired through our lifecycle management rules. So when it comes to compliance or the lifecycle management of the data itself, we do have the features in place. When it comes to replication, you can control it. Yes?
Yeah. So one follow-on question is, do you actually have a capability to optimize this for cost?
Yeah, so I also want to complete the previous question. There are two types of replication customers ask. One type of replication is I want to be able to have a granular control, like how you asked. Some data I want them to be able to share. I want them to be able to delete, modify whatever they want to do with it. But if whatever changes they do there, I want that to be propagated back here. These are two different teams operating on the same data set at two different time zones. That's possible. But then sometimes they would say that I want this to be like the master data. Copy is made instantly. They want to all the mutations are allowed but never propagated back. Sometimes some data that you don't want to be shared at all. The way they do it is the data is organized in terms of buckets. Buckets are like the volumes, like LUN or NFS export from the NAS world. You set these policies at the bucket level, and that's how you can control what data, who can access. And the policies are identity and access management are global. They link all the deployments across the globe. So that's how the policies are universally applied. And the policy definition can tell which bucket, which user, what APIs are allowed, and what objects, prefixes, even tags. You can be more fine-grained there. And they can be applied to selective buckets and selective objects. But sometimes customers, like in some cases, like in telcos, we have seen that they actually want three-way active-active cross-geo replication. And in that case, they want, say, if I apply a bucket policy, if I create a bucket here, if I apply a bucket policy, immutability, like ransomware protection policies, whatever, right? I don't want to be going to 3 different data centers, because if I forget, then the data that's applied there, I don't want 3 different administrators coordinating between them. It leads to a lot of confusion. Whatever happens on one side, I want those regions almost like a stretch cluster or zones in cloud context. Anything I do here, I want to be, even the policies to be automatically applied. I create a bucket here. I want the buckets to automatically apply, be created there with policies inherited. Both modes, site level replication, bucket level replication, both are supported. In bucket level replication, you can be more granular. If you want, asymmetry in your policies, you do bucket level. If you want everything to be entangled as one big giant site, but spread across continent, and even across cloud, you would go for site replication.
Okay. I mean, I follow all that.
Yeah.
It's how easy is it to manage all the various different buckets? Like we're talking about 1 or 2 buckets in your examples here. What happens when you have thousands of buckets? Is it all in one big list?
So the way typically we see these enterprise teams, what they do is they follow somewhat closer to Kubernetes multi-cluster model. Like even if you see in Kubernetes, for example, right, like every application team, they want all the controls, but then if you empower them completely, then you can't have multiple administrators to a single system. Okay. Then, right, so you have the same problem in object storage too. How does Kubernetes solve? What they do is, instead of telling,
as far as I can tell, they haven't.
Yeah, so even Kubernetes is not mature enough to say, even though it's supposed to be multi-user and all these ACLs, you can have multiple administrators, different namespaces, but almost always they never build a single large global namespace, single large Kubernetes cluster across the cloud. Instead, what they do is different teams, they have their own Kubernetes cluster, and then they have basically it's a multi-cluster, and they use a service mesh to link them, and identity manager and stuff like that. This is more manageable, but then if you bring your application and you want a specific version of Kubernetes for certain compatibility, you are the administrator for your Kubernetes, and everybody runs their own Kubernetes, but then they are all linked as one multi-cluster setup. Now, in case of MinIO, the way they actually like the same model, that some different teams, they actually even spin up different tenants, because it is a simple requirement. one team would say, I want the latest and greatest features. I want to be updated, MinIO to be updated to the latest version. Other team would tell, don't touch it. It has been approved, vetted by the InfoSec team. You cannot upgrade without permission. And how do you deal with this problem? MinIO dealt with the multi-tenancy very early on. This is why if you see MinIO is lightweight and just 100 megabyte binary means you can run dense multi-tenant microservices like setup. Every tenant is completely isolated in their own MinIO namespace, and every namespace can be their own admin. That way, this team, so your project or your application has these 10 buckets or 20 buckets. You want to manage the policies. I as an infrastructure administrator, I'm going to give you control for your, if you are the product owner for that particular application or that particular region of the application, I'm going to give you control. If you want flexibility without running into someone else's policies. So they not only do deal it with bucket level, they also deal it with the tenant and namespace level. It's the multi-cluster model that they brought into Kubernetes is the way they deal with MinIO2 through multi-tenancy.
If I can clarify one thing for the audience here, when we talk about multi-tenancy, we're talking about multi-tenancy within the Kubernetes cluster, right? We're not talking about multi-tenant environment with many companies, each of whom gets their own dedicated, separated environment.
Because I keep hearing a lot of mixed terminology between cloud terminology and on-premises terminology. So, because you're talking about spinning up buckets and an infrastructure engineer. So, what is MinIO doing with this multi-cloud? Are you guys hosting the data, or are you spinning up buckets? Where does the data? Are you hosting the data, moving the data in? Like, where exactly on that very basic level is this happening?
Yeah. So, what do we give to the customer? What customers do? Our job is we give them software. And they want to be in control of the data, and they want to be in control of the technology. They want to deploy the software where they want to. So we are not a storage as a service provider like cloud storage as a service like S3. We don't give them appliance. We just give them software, just like you would get MongoDB or Elastic or Splunk. Now they deploy it on the cloud. We just made it easier through marketplace. You can click and deploy, or there are Kubernetes YAML files. You just can deploy on any Kubernetes environment.
So who would you say your competitors to this are then?
From day one, we have always told our competitor is AWS S3, but then we took a very different approach. AWS approach is everyone come to AWS, we got you covered. I give you ready to eat, ready to consume storage as a service. Our bet has always been bulk of the world's data is not only is going to be all over the globe. Only a tiny fraction of the data will be produced inside AWS. And if that means that everywhere else too, they want AWS S3, but AWS S3 will be stuck within AWS. Our bet was, if we gave a software that runs inside AWS and on all the cloud, on-prem, everywhere else, then customers will be able to take their software and deploy it on any cloud, take the data anywhere they want to, and also deploy MinIO where the data is getting generated. So we just give them the software, customers deploy us inside AWS, on Google Cloud, on VMware, anywhere else. So in that sense, if you see, we are in some ways, AWS S3 and us, we are going after the same user base, but with a very different approach.
Well, it seems what you've added is you have this management layer, which is part of the question I was trying to ask here is, the management layer can control MinIO wherever it is, but the compliance was the first question, and I wanted to follow up again. Is there any way of actually seeing or controlling costs with this? Because all of your cloud providers actually have costs associated with them. If you just allow people to move stuff between clouds, you can, basically bankrupt your company. By trying to play stuff in all the various different clouds. Do you actually have a way of seeing the costs and making sure that your developers aren't bankrupting the company?
Absolutely. It is actually, cost is a bigger concern, particularly at scale. At a smaller scale, when the application teams went to the cloud to just launch the project on time, they couldn't wait for IT to provision these resources. Because buying a machine, provisioning, setting it up, it takes time. They went to cloud, it made sense. But beyond productivity, once you start scaling, cost becomes a biggest factor for all these. We have seen some of the largest like the largest deployments of MinIO, they actually, I see that they leave AWS and go to Equinix, and then the applications are still running on the cloud, but the data infrastructure running on Equinix, and then they turn around and provide a data storage as a service for multiple clouds. But that's only for the largest end of the spectrum. But within the cloud, how do they deal with the cost? Daniel, can you go into the operator console?
Yes.
So this is how the division of roles within the organization is happening. Generally, we see there are three teams. Applications team, who owns the application. They are better equipped to like make changes, push multiple times a day. They even manage their CI/CD infrastructure. Deploying and managing, their lines are even blurring between DevOps and the applications team. They can, while they know how to push updates, how to manage their application infrastructure, they are not really DevOps people. But even from DevOps side, DevOps is again more of operations. But the real cost part, what we find is enterprise IT understood better when it comes to security, when it comes to cost and budget, uptimes and SLAs. Their goals were very different from applications team. Enterprise team is security and cost. Applications team, it's all about productivity. But then both of them were needed. It's not like one is more important than the other. Finally, we are seeing that how we can bring all of them together. And in many ways, what Kubernetes did was the DevOps part, it kind of commoditized by allowing software vendors like us to productize what DevOps used to do. Right? Previously, almost every DevOps, whatever they wrote as Ansible and Chef and Puppet scripts were not reusable. And if one DevOps leaves, then like other one will start all over from scratch again. It was unmaintainable. So Kubernetes operator basically productized that and put a nice simple API and a nice front end. It made us, it became possible for us to do it because of the operator. Now enterprise IT is able to set these boundaries. Without the operator model, if you gave complete control, applications team wants productivity. You cannot come in the way. Every IT tells that they actually don't want to be coming in the way. They want to give self-service. But if you give them full control, they go rogue on the cloud. They spin up instances endlessly, and they will never turn it off. And you ask them which is important, they will tell you everything is important. Can I delete this bucket? Can I delete this data? No, don't touch it. Even if it is temp data, they will tell I need it. And so how do you deal with this?
I think you've clarified my question, but I don't think you've answered it.
Yes. So now I'm going to the operator console. So within MinIO, there are three parts, right? The applications team, all they care is the API. They give me a bucket, give me endpoint, give me access key, secret key, and a bucket. Now applications use S3 API to deal with it. That's the API part, easy to understand. Then the object storage admin, from a database world, it's like the DBA. They are the one who creates buckets, set policies and stuff like that. But they like, you know how to create tables and schema and stuff like that. They are object storage admin. They know how to write good policies and stuff like that, but they are not infrastructure administrators. How do you give them self-service? The infrastructure part, you want to separate it out. This is the infrastructure, the operator console is the console for the infrastructure admin. They don't need to know how S3 API works, how the bucket policies work, all the low-level details. Like a sysadmin on a Linux box, they know what's the right version of Postgres or Elastic, how to set up the storage networking, and all of that they know very well, but they have no idea how to be a DBA. So the operator is basically the sysadmin, modern day sysadmin from the enterprise IT part. Go create a tenant, Daniel.
Really quick a comment before I go on to create the tenant, because I think one of the things that the question is seeking to answer is about cutting costs, right? So as an infrastructure, the fact that you can provision different tenants, for example, I have here my production hot storage. This one's using NVMe, right? But I also provisioning tenants that are, cheaper, right, in their capabilities. So I'm using slower drives, but they're cheaper as well. And I'm actually lifecycle and tiering the data from a hot tier into the warm tier, right? And this is transparent to the application consumer, right? He's still consuming the data. He still sees the buckets. He doesn't know if he's pulling the data from a fast medium or a slow medium, right? Me as the owner of the infrastructure, I'm controlling that part.
Yeah. The infrastructure administrator wants to set the boundary conditions that you can only use this much of instances, this instance type, this much of capacity, and even from security point of view, organization has standardized on Azure AD as the global identity manager and Gemalto corporate control key management service. They are in a better place to enforce these rules, and they set the boundary condition. If you are my administrator, you would set these conditions. Within those conditions, you would give me full self-service control. I'll show you that too. So when you as an administrator, pretty much infrastructure administrator, these are pretty much the things that you care. And you here in this screen, you can actually set the boundary conditions. And okay, you cannot use more than you cannot use more than say 16 instances with this much of capacity, because if you leave them running, I know that's the budget I allow you. And once it is all set, right? This is like how internally inside AWS engineers would work. Now, if you see the console, the object storage console, this is basically how, if you are an AWS customer today, you don't know how internally it works. When you log into the console, it's ready to consume. You now start creating buckets and you can do whatever you want, right? This is the part that I, as an infrastructure administrator, once I've set these boundary conditions and created a tenant for you, I would give you a URL, access key, secret key, and then when you log in, basically you would find nothing different from AWS-like experience. And you can do everything within those. Whatever you do here, it's going to feel like AWS, but it cannot exceed the conditions set by the infrastructure administrator.
So does the infrastructure administrator have a view to those costs within this portal, or
yes,
they still have to go elsewhere?
The infrastructure only, because if you are my admin, you have given me the control. So now I can use whatever I want. Previously, if I can endlessly create resources and I can go rogue and there's no one controlling me, but you have now set the boundary conditions. In fact, even the billing would go through you. And anytime you can suspend my tenant if project is abandoned, you have complete control over my tenant instances. And all the billing also is controlled by you. Everything goes through you. You have to approve. But that way, you are focused on infrastructure side without worrying about or coming in the way of regular day-to-day application management.
I have a question around
Sure.
Around the performance. You've said you're the fastest object store in the world, basically, but you've also said you're providing software, which means you're at the mercy of AWS's storage speed and the other cloud providers' storage speed. As a network person, there's a disconnect for me. Where does the speed and performance come in when you have to rely on the hardware speed of the cloud providers, which every other, all your competitors would need to do the same thing?
MinIO's performance guarantee, the way what we always tell the customers is we can be pretty close to the hardware speed. We always measure the drive and the network. Because we are IO bound, we can either be as fast as the network or as fast as the drives, whichever is the slowest component. And the more nodes you add, it keeps scaling. In the cloud, like you choose the instance type. If you choose the NVMe class storage and 100 gigabit network, the more nodes you add, we can actually show you that we can saturate the 100 gigabit network, because NVMe drives, they are pretty fast, like anywhere between 2 to 3.5 gigabytes per second per drive we can pull data, and it almost always chokes the 100 gigabit network. And from a customer point of view, it depends on, like, say you want to do an AML application, you want all the performance you get. How much performance you get is simply a function of number of containers you can launch.
So here's an elemental question. Let's go down to the lowest level.
Sure.
Okay.
Yeah.
Security. How do I make sure that when I need security, I mean, highly encrypted files for whatever reason, like everything, just to be safe. How does your product ensure that people don't accidentally turn off encryption?
Yes. So within security, we are talking about encryption in specific. So this screen, first from an encryption point of view, the application side, they look at object through the S3 APIs. And now there are 3 different models that are supported here. This part of the S3 API specification too. One is the server-side encryption. You as an application, you don't care. All the data that's stored is encrypted on the server side, and the server talks to a key management server. Then there is another type from the server side. Amazon calls it SSE S3 and SSE KMS. SSE KMS can support multiple key management servers, but they're essentially otherwise similar model. Then there is another model where the encryption happens all the way from the application side, because they want to encrypt and then upload the keys. Actually, the way it's called client supplied. So the client side encryption, or client supplies the keys, but server encrypts it, right? So the keys are that way managed by the application. MinIO supports all of these modes. Now, you don't want the application to override any of this. Say, I'm the InfoSec guy, and I want to make sure that you cannot override any of these settings I do. This is why the security part, if you see, this is these settings are actually part of the infrastructure administrator. Once the infrastructure administrator chose that you are going to use a AWS encryption service, or like Keycloak, or one of them that you pick, right? So once the setting is there, you cannot override it. And the keys, the way MinIO works, the keys actually, these ones are typically, these key management servers are not high performance. They are only good at giving you the master key. The master key actually comes into MinIO, and MinIO has its own key management service, which is stateless, and it creates derivative keys. And every single object is independently encrypted with the derivative key. That's like, even if it is exposed, you only expose that particular object key because of some application bug. There is no way for them to go override, because the master key itself is not even exposed to the MinIO tenants. There is a key management server in between the master KMS and MinIO that uses the master key and creates derivative keys for each and every object every object that's created on the system.
Okay.
And there is no way you can override all these settings.
But bottom line, is there a way for me to say, take it from more the storage admin perspective? Yeah, we're still out here, right? To say, okay.
Admins are dead.
Mostly, but or they become DBAs. But what?
Never.
Okay, I'm going to make them. This bucket is encrypted, and you can't turn that off. That was my question.
Yes.
That, and MinIO absolutely supports that.
Absolutely.
Okay, and the user doesn't know. The user has no way. So if a developer comes in here and goes, "Well, I don't think it's running fast enough. I want to turn off encryption," because they think that's going to make a difference.
Yes.
They can't do that.
There is no API for them to do that.
Yeah, that's what I asked. Okay, perfect.
Yeah. And even you can see there are 2 levels of administration. The infrastructure administrator, if they set it, even the tenant administrator cannot override.
Good.
Or the tenant administrator can choose to enable, disable, but within the constraints of the infrastructure administrator.
Okay.
Yeah, I mean, yeah. So the main takeaway from this part is that the owner of the infrastructure can do, he can enforce sizes, as AB was mentioning. They can enforce configuration, encryption, security, all the certificates, the TLS. They can encrypt it, even identity management. I've been showing you over and over. I secure everything through OpenID here, right? So I have single sign-on everywhere. But if my company was using Active Directory, I could also enforce that, right? So if my developers need to access the object storage, they can authenticate via their Active Directory LDAP credentials, let's say. And then in turn, they can create the credentials for their applications to access the object storage. So let's say here I have an application that I deployed into Amazon. I have a raw ELV deployed here. I'm pointing to my object storage is on one of my MinIO domains, right? I can deploy the exact same application on Google Cloud. Google Cloud doesn't give me ELVs. They give me like static IP addresses. And then, right, this is a TensorFlow application where I can go and give it an image. Let's say this is an image I took this morning with my daughter to make it look live, right? Because this is like a TensorFlow application, right? And at the end of the day, TensorFlow doesn't really care where it's running. So it shouldn't care about its storage either, right? So the fact that I can just point the application to a different location right? It makes my my life as an operation administrator just much simpler, right? Because I no longer have to deal, okay, rewrite that pipeline to work with different type of storage, right? From Azure or from Google Cloud. It's just the same API all over the place. So it's one app, all clouds. It's just way simpler, right? That was the part. Now, we also covered, right? What if one of these clouds goes down, right? So can the model persist, right? So this is something that we touched also like out of bound. I was showing you replication, the active-active replication, or continuous data protection in a sense that where I'm putting the model, and as soon as I put the model, it's traveling across to the other clouds in a synchronous fashion. Every operation in MinIO is atomic, right? So as soon as I put the object and I get that 200 status reply, I know that the file is already replicated to the other cloud as well, right? So this is the other part of the demo that we already touched. And
just go ahead and upload a whole bunch of files, right? One file is easy to show a demo, right? Just show. In fact, like it's even synchronous. We even support strict consistency across cloud, and it can be a synchronous multi-site active-active. And browser doesn't refresh because browser is just a viewer, right? But from an application point of view, if you have a distributed application, even it could be a spanner-like database. These are like geoscale databases. They actually write table segments across these distributed data store, and they do change data management on top of MinIO. And everything that you you commit to MinIO is instantly replicated. And nanosecond later, you read from the other side, it is supposed to be strictly consistent. And this is also because of the MinIO's metadata-less architecture, we were able to achieve strict consistency at high speed. You can get performance or strict consistency, but trying to get both is very hard. And this is because of the MinIO's design, we are able to show strict consistency, active-active multi-site replication, that any one of these clouds like going down, like you're talking about cloud scale high availability, that like even two of them went down and one cloud is still running, your application still keeps proceeding normally. The load balancer that can sits in between, they completely abstract all these details.
The replication between clouds and presumably around the world is synchronous. That has a significant impact on latency. Your write transactions are not going to complete before tens of milliseconds. Is there an option for not having that strict consistency, maybe at bucket level?
Yes. So yes, it is at the bucket level. You can choose when you do the replication that you can do strict consistency, or you can do near synchronous. It's a non-blocking commit. Still here, it will feel like everything is synchronous, but it is not atomic. As soon as the application, if I upload an object to site A, as soon as the object is committed to the local cluster with erasure code and bitrot, all the protection, if it's locally committed, it doesn't have to wait for the multi-site to catch up. It will respond 200 OK for the application, and it will immediately push it. If there is sufficient bandwidth and latency, all the clouds will feel like it's synchronous, but you cannot expect strict consistency across. Most of the time, actually, they don't need strict consistency, but it feels like it's synchronous, and they are quite happy with it. Even AWS, they are talking about cross-region up to 15 minutes of SLA. They are actually talking about every single object immediately getting pushed. We are talking at 150 millisecond latency, like cross-geo, and it's still, if the commit immediately appears there, customers are happy, but option exists. You can choose at the bucket level.
Yeah, the reality of object storage is most of the time you're only writing in one location to a particular object. You're not going to overwrite that object in another location, or typically the client is for that object is in one location only at a time.
Yeah, actually that is mostly true. In fact, most applications, they don't even care about list and namespace. They actually use it as just a blob store. One thing that has started changing now is databases are actually using object store more and more as their backend. They actually bring the block storage SAN-like mentality. We actually see even the Veeam and Rubrik, Quacity, Actifio type workloads, they actually brought block storage behavior into object store. And for them to do dedupe type capability, they actually now start relying on some of these capabilities. But in general, your statement is correct. from application point of view, they don't even override. They write once and there is no API to even modify the object. You just keep creating new objects. They hardly even delete.
And another thing, the replication, you can also set it up within the same bucket across different prefixes to have different SLAs, right? You could say, files that are landing on this prefix within my bucket, I do want synchronous replication because it's very important data. And the rest of the bucket can just go in an asynchronous fashion. So that's also supported.
Let's go to the
yes?
let's go to the versioning and the immutability and protection, ransomware protection, that capabilities. So you can choose these capabilities at the bucket level when you create, but let's go into the object versioning.
Here I have a file that has been overwritten multiple times. It's a JPEG file, and I can see I'm already at my 5th version, right? It's a cat picture over here. But let's say this means that probably the previous version was different, right? And you can see that even though it's been overwritten multiple times, it's different versions all over the place. I still have every single version, right? And this is part of our continuous data protection strategy, where you don't have to worry about doing snapshotting of the data or how did like taking backups of your own object storage, because the fact that we're keeping the versions through time helps you even see if you want to go back in time and say, okay, how did this bucket used to look like last week, right? So let's say I want to go back to say, okay, even last week, maybe Monday. Let's see what I had in my bucket Monday. I didn't have anything in this bucket on Monday. We can check any other day of the week. Let's say yesterday, right? Yesterday I had 2 files, right? So I can go back in time and see what was the state of my data back then, right? And even download those specific versions of the files that I had in that time. And I can then, I don't have to worry about, backing up my data, snapshotting, etc., all of that part.
If you see the rewind capability is actually at the namespace level. You can point it with, here there is no snapshot, right? And snapshots are not scalable. Snapshots work okay if you had a small export, NAS export or a small LUN, and it's usually done by administrator, and any crash, you can only go back to the point in time that you did snapshots. But that's not sufficient in the modern data world, particularly database type applications. They rely on every single commit. They actually want continuous data protection like capability. So every single change to the namespace, they want to be able to read, but it's not like you have to restore. All those versions has to exist. Depending on the database queries you type, the database would actually pick different change based on the change log. They would actually query the right segment of the table, and all of that they rely on this kind of capability. Here we just showed a cat image, but in real world these are like table segments that every single mutation you would perform at the database or the AML applications, they are tracked here, and simultaneously they actually pull different versions of the object. Snapshots would not work, would not scale, and as an effect of this, right, this also makes the object store immutable. Every single change, now I'll transition from the versioning part into the immutability part, which is where the ransomware protection type things come. They are actually built on the same versioning capability. And the way it works is, say today if I got breached, if I told the applications team, hold everything you are doing, I switched everything to read only, until the security team completes the audit, you cannot make any changes. That's not going to work. Like the right way to deal with this is everything moves as normal, and every change you continue to make. But whatever data that is written, if you go tamper it, the tampering is a new version of the object. The object that looked at that point in time, you cannot go back and delete.
So you're talking about within one object. You're not talking about necessarily consistency between multiple objects.
If it is done at the object level granularity, like if you saw in the object viewer you saw within an object, right? The rewind actually is at the namespace level. If the object level is tracked, then I can tell at this point in time, each and every object exactly how it looked. Now I can give you a view. That's what the rewind did. And now the compliance part, right? If I told that you cannot, all objects, the right policy is don't react after the attack happened. What if I told that every time any object that is created within this bucket, by default it is locked? That means that you may be the owner of that object or the bucket. Whatever you do, you cannot tamper what you created yourself until 6 years. That's basically like, I'm just setting that policy. You can go delete it, and delete becomes a new object marker, and you override it. It's a new object across the namespace. But after 6 years, now it's no longer regulated. So I'm allowing you to delete. Nobody even remembers to go delete them. That's where you would actually set up a lifecycle policy. After 6 years, it would automatically go clean them up if you want to. So that's how you manage it. So nobody wants to delete object. No one, even if you give them the control, they don't delete it. The right way to deal with this is let them go do all changes, everything that they want, and the data keeps growing. But beyond the regulation period, let the machine clear it up based on policy. And that's where the lifecycle management comes. But even lifecycle management cannot go and delete the data if the locking policies are enabled. Like today, you can go and delete a version. See, I created an object, delete object becomes a version. It is possible for you to even go delete the version of the object itself. But if it's locked, you cannot. Everything is a new version, and you can no longer mutate the system.
So on that, AB, some legislation in certain jurisdictions requires you to delete information from time to time, which might be stored in an object. So presumably there is a way that I can definitely do this. Also, some information, like I don't want it to be kept, because the data that I have kept could be breached. Like one of the things about ransomware is that not necessarily that they'll encrypt it, but they might just copy it somewhere else and then release it. So I want to delete things.
Yeah, that's a good point, Justin. Actually, that's exactly why you have two different forms of the immutability. Daniel, can you go to that screen, bucket creation? There is a compliance mode and a governance mode. And even initially for me, every time I will read the documentation, I'll try to remember there are two modes that look almost similar, but there is a subtle difference. And this is the reason why it was created this way. One of them, you can lock it, but as an administrator, you can go and relax it and then go override it. The other one, even as an administrator, you cannot override it. There may be certain, like say, email content that that you cannot delete some things. If you want to, even as an administrator, if you set it, you cannot delete it. That's one mode. That's why you have compliance and governance mode. The other one gives you the same exact capability, but you as an administrator can override yourself. Only the administrator. And they're all, if you see like this capability, even the replication, right? You cannot possibly just do active-active replication with just two sites. You create a split brain situation. And how do you achieve this? Because object storage supports immutability at its foundation. If every single change is a new version, it behaves like an immutable read-only site. If I have two read-only type operation, right? It's easy to create active-active. It's almost behaves like active-passive in cross-section. A lot of the capabilities of the object storage are very much built on the versioning foundation. And like continuous data protection was impossible. I wouldn't say it's impossible. It's very, very hard to achieve in SAN and NAS world, because I can make just 1 byte change, 4K change. It's so chatty changes. It's very hard to keep track of every single change. The change tracking will be larger than the data itself, and it would slow the system so bad that it will be unusable. Whereas an object store, by letting go some of the capabilities, like the core, like object level mutation, the object storage achieved continuous data protection. Because every single object, every single change is a new object, finally you got continuous data protection. And all of this, you don't need to worry about how, as an administrator, you're versioning, you're snapshotting or anything. It's just policy, you set it, and you got the capability. From application point of view, finally, the databases are now relying on object store to actually build sophisticated database backends, because they can look at multiple versions. Like they previously could not read across snapshots. In this case, they can read across versions of the object. Like you're in a queue continuum, you can see across time, you can exist in multiple timelines simultaneously, is how the S3 API works. And you can read different versions of the object at the same time. Even from the command line point of view, like MC has a unique core-utils like a tool chain, and you can, simple things like ls and cp and find like commands, all you have to do is -- as off, and you give a time, at that point in time, this subdirectory, copy all my objects into this subdirectory, you could do things like that. Finally, it became possible because of these capabilities.
That's just abstraction at your level across all those. I just want to reiterate, that's really the power, right? Is you're just making it all consistent and abstracting everything so that, you can have your data everywhere and still
exactly,
but be a consistent and I guess standardized. I don't want to use that word because I'm not a storage person or cloud guy, so don't. So,
yeah,
just okay.
Yeah, and the standardized, right? It's if you see if you go from one cloud to another, it's not just the API alone, right? Like all these things are so different. The capabilities are not even like they're equivalent. They're missing. AWS has a huge lead here, and the rest of the cloud are so behind. And you can't even map the security policy document or these compliance policy. Like, how do I go from one cloud to another and make sure the same ransomware or compliance policies are applied? You cannot even apply because there is no equivalent functionality, and most of the time they're missing. And this is just one part of the critical capabilities, right? We have seen like I can't name some of these customers, but they are the most popular cloud databases. And when they moved from one cloud to another, originally they thought that they could write a shim layer that just abstracts, like I will natively support Blob API, I'll natively support Azure API. They found that it's an n-body problem. It's actually very hard. They almost ended up building their own object store. That's where they realized that it's easier for them to just ditch it and then bring MinIO to do the job. But then there was one more important requirement they mentioned. Daniel, go into that speed test, right? Performance is actually another important requirement, particularly for high performance applications in the cloud. When they went from one cloud to another, they actually said AWS S3 previously, when they were on S3, AWS S3 met their performance SLAs. They were amongst the top heavy load consumers of AWS S3. But when they pointed to GCS and Azure Blob, it just fell apart. It did not scale. This is something you would find very common in the analytics world too. And they wanted same consistent high performance everywhere. So how do you really achieve the standard? In many ways, the simplest thing is standards are more like guidance nowadays. The standards are set by the market leader. And even S3 API is not a standard. It's more like I feel like it's a religious text. All the API specs they published, there are many interpretations of that spec, even by AWS own SDKs. The only way we could get it right is to just have a large install base. So if we broke something, all I care is not the standard. If your application runs the same way it runs on AWS S3, then we are compatible, is the one that we really care. And every single application you bring on board, if it works there, it should work here. If it works better, I won't complain, but it should work exactly the same way. And by the only easy way to achieve this is put the same software on multiple cloud, you got the same capabilities. And built for high performance, like this one, you can see that even performance part is so important. We actually embedded a benchmarking tool inside the MinIO itself. So you can just click from the browser and see at any given time, the performance SLAs are met. A lot of times that sometimes the performance degrade over time. And then anytime you just click the button and tell me how fast it is. If it's not, then sometimes you will find like a node level, right? It also becomes an effective benchmarking tool. You can see, oh, did you see that fourth node is slow? Maybe the drives are going bad, right? Or the network is a problem. Performance is something our users look at it on every single day. If performance goes down, it's actually considered an outage for them. Applications start seeing 503 errors. And how do you get consistent performance across all cloud? Today, if you just go from one object storage to another object storage, assuming that API is the least of your problem, you will find like performance problems, the compliance and regulations and all those other, like how do I even set these policies? How do I standardize on one encryption server? How do I set up an identity manager? The biggest complex part is actually the operational part. Setting it up itself nowadays, like just configuring identity, access, external identity for one cloud is daunting from AWS point of view. How do you achieve unified identity, unified key management server, unified policies that as an infrastructure administrator, if I say we are ransomware protected across all clouds, today it's an aspiration, right? How do you achieve that? This is where customers found that by putting MinIO everywhere, even all the way to the private cloud to edge, and linking everything to common identity, common KMS, one single policy that is pushed centrally to all the deployments, they're able to achieve everything. We pretty much actually covered everything. Yes, actually go ahead and try. The small objects is something interesting. Just like in object storage, we thought initially most of them are blobs and you just write and never erase. And it was a simple workload pattern when object storage was growing popular in the cloud in the early days, because those were web applications. And most of the time they will create the object names are hash. They store the hash in the database. They don't even do listing on the database. It was on the object namespace. It was a very simple workload pattern. Nowadays, when I look at the object storage workload, it's very sophisticated, very complicated. It's almost turning into an IOPS type problem too, not just throughput. I initially thought object storage was purely throughput, but nowadays I'm finding that as the databases comes into object storage world, the IOPS are becoming important too. But the IOPS are not like 4K blocks. These are like typically 1 MB, 2 MB chunks. I do see that sometimes 100K, 64K type, pretty much all the objects in the namespace are 100K. Like PayPal is a good example. There's one of the core deployment, if that goes down, like PayPal would go down, right? And bulk of the objects are actually below 100K, anywhere like 20K to 100K. And historically, I would have told them, such a workload, you're better off sticking it to a database, right? Like a Cassandra type data store. But what I found was the problem with the data stores, they are okay if you're having small amount of small objects. But if you have petabytes and petabytes of large objects, then you also have very high durability requirements and performance requirements. There is no database that could scale here. The clean way to do it is every single small object is erasure coded and striped across many nodes. So you also got high durability. And MinIO was able to meet their performance SLAs. And that's how the object storage workload became more complicated. And then a combination of databases started realizing that they have to scale anyway. Databases provide nice access layer, query layer, and query processing, but they realized that they can piggyback on high performance object store and they can scale for handling large amounts of data too. The recent trend in the database world, what I'm finding, pretty much all the data is coming even directly to object store as collection of Parquet data sets. And then from Snowflake to Teradata to SQL Server to all the popular databases, now they support external tables. They actually pull the data from object store, they process all they want, and then they commit the results back to object store. Seems to be the most scalable approach. But overall, the pattern now is shifting to small objects. And small objects is something that only, I don't want to comment about other object storage systems. The problem that they generally run into is their metadata database themselves, they use Cassandra or something like that. And they fall apart very quickly, it doesn't scale. And MinIO's model of no metadata database, every single object is completely self-contained and erasure coded. We were able to achieve like high IOPS, high throughput, and still keep all the strict consistency. This is one of the important reasons why MinIO is growing popular in the database AIML workloads as a primary storage.
One quick comment: when I did the performance benchmark, this hardware is 32 servers. It's rated for a read throughput of 152 gigabytes a second, and I'm getting 147, right? Pretty close to what the hardware can give me. And you can see that when we switch to small objects, the IOPS went through the roof, right, compared to large objects. And still, I'm probably being bounded by what the hardware IOPS can give me, but still, I'm getting like a great performance.
One detail there we noticed in the cloud compared to on-prem, like say if you got a Dell or a Supermicro server, the SSDs, we are able to get like 3+ gigabytes per second on writes 2 to 2.5 gigabytes per second. On the cloud, it's like 1.5 max too, right? We usually typically get around 1.5 gigabytes per second. And well, cloud is not as fast as the servers that you can buy yourself, but it's still plenty fast. And in aggregate, the drives compared to the network are faster than the network. So overall, it evens out. But this benchmark is a cloud benchmark. If you run the same benchmark on your Dell server running Kubernetes and MinIO, you would find that it's actually going to be double this number.
Yes. Yeah, because on these nodes, I couldn't put more than 5 in NVMEs because, as AB was mentioning, each NVMe is rated for 1 GB a second, right? And then for these VMs, I'm only getting maximum 4.75 gigabytes a second of throughput. So why put more drives into the VM, right? The cloud vendor is not going to give me more throughput than that. So that's why the setup is laid out this way. But yeah, on premise, you will definitely break or double this at least.
So in terms of what makes MinIO fast, so one, again, we only do object storage. So we're not making any compromises to do other things. That single layer allows us to be super fast. AB talked about the metadata database. I'm not going to weigh in on that. The other thing that we did is we did all of the really hard work around SIMD acceleration. So very granular, very, very hard work around chipset optimization. And then we wrote it all in Go and Go assembly language. And that allows us to basically target the task in terms of the performance perspective. And that's how we get to the speeds that you saw earlier. So in terms of what the future looks like from a cloud storage perspective, our perspective is obviously informed by what we do, right? We do object storage. We are software defined. But we see time and time again that the ability to run across multiple clouds, to run as a software defined model allows us to basically be targeted to any platform that you want from a cloud operating model. Right? We think software eats everything over time. The next part is that we just continue to see this movement toward disaggregation, right? The free fall of the HDFS and the Hadoop ecosystem has been well documented, but it's really fundamentally comes down to disaggregating storage and compute and getting the best of both in this world. And we continue to see that in Kubernetes is obviously a huge accelerator of that. It's basically the compute platform of the cloud. And then, finally, we see multi-cloud becoming a core requirement from a corporation perspective and an enterprise perspective. And the bigger the enterprise, the bigger the challenge it is for them. And that's the problem that we're trying to solve.